This video will briefly introduce active cylindrical metasurface with spatial reconfigurability for tunable backward scattering reduction. The relevant work can be found in IEEE transactions on antennas and propagation. Most of the traditional metadevices for backward RCS reduction cannot be dynamically tuned once fabricated or just with limited working bandwidth. Revoking the passive constraint by active metasurface loaded with tunable components will open up a way to manipulate the performance dynamically, thus providing possibilities to realize time division multiplexing of operating spectra to equivalently expand the bandwidth. However, it is still challenging to design ultra-thin conformal metasurface capable of well-suppressing backward scattering with widely tunable operating frequencies. To overcome this problem, this work presents an active cylindrical metasurface with spatial reconfigurability to achieve dynamic control of the RCS reduction. We start from designing a passive conformal metasurface to suppress backward scattering by using the composite strategy to improve the operating bandwidth. To equivalently improve the operating bandwidth via time division multiplexing, we finally implement an active cylindrical metasurface by loading voltage-controlled PIN diodes on the modified passive metasurface to achieve tunable RCS reduction bandwidth assisted by spatial reconfigurability of metasurface structure. It is noted that conventional metasurface with PIN diodes only have limited abilities in tuning the working frequencies, for example, switching between two frequency bands. By introducing the concept of spatial reconfigurability, this work proposes a method to realize versatile surface impedances of a metasurface by switching PIN diodes only, and addresses the issue of achieving flexible tuning of working frequency over continuous and wide bandwidth. We then fabricate an active metasurface prototype. Both simulated and measured results demonstrate that by reconfiguring the metasurface spatially, surface impedances can be manipulated dynamically, resulting in high-efficient backward scattering within a broad continuous and dynamic band while keeping its ultra-thin thickness at lower microwave frequency. More details of the work can be found in the reference. Thank you for your attention.